Right, so what we got here is a cooking thermometer that I've taken to pieces. It is one of these which has got this style of bit on the end, screws together like that. Then you got the cap on the end, the LR44, the battery sits in the end like that. And you got your two push buttons. So that sits on this little PC board over here. So there's a display and looks like that. So you got Celsius and Fahrenheit selection and you're on and off. Now how they work is it's actually got a diode in the end here, and as you change the temperature, the forward voltage across this diode changes. Alright, so I've got it hooked up to an Arduino. So my breadboard probably not making the best contact, as they do. So I'll let it settle down now. If I put my finger on the diode, you see the temperature coming up over there. Now how it works is for every degree C of change on the diode body, you get 0.2 of a volt change in the voltage. It's an NTC diode, so the voltage drops. Alright, so it's settled down. So when I warm it up, there you can see the temperature coming up on my display. You can see the voltage coming up. So it's about 1.72 volts at 20 degrees C. Around there. So what I've done in the code, I've got a 4x20 LCD hooked up to it. So we have got wire.h for the LCD and liquid crystal.h. So that's your I²C and your liquid crystal libraries. Alright, so you got your address 27 and it's a 20x4. Sensor pin is A0. Your reference voltage is 5 volts and ADC resolution is 123. Also it's a 10-bit ADC. This is a Arduino of3 that I'm using over here. So your millivolts per degree C is 2 volts as your constant. Room temp is 20 degrees and your forward voltage at room temp is 1.735. Okay, so that's your starting point. Those are your reference values. So filtered voltage, you start off at 0. Constant float alpha, that's for my exponential moving average. Okay, so in the setup you initialize the LCD, turn the backlight on, set the cursor to line 0, position 0, print diode temp sensor, and wait a second. So if I reboot this, it should do that. Yeah, There you can see that coming down because that's an exponential moving average for smoothing, so that your reading doesn't jump around. We then read analog pin 0 and we convert the raw voltage into voltage. Filtered voltage then becomes our voltage with our alpha from the exponential moving average. We then calculate the room temperature from the smooth voltage, which is room temp, plus your forward voltage minus your filtered voltage times 1000 divided by millivolts per degree C. To display it, we set the cursor to line 0, position 0, and we print the voltage. So we have some text and then the filtered voltage and more text. So that's it over there. For the temperature, we set it to position 0, line 1, print temp, print the temperature, print a character for degree C simple, and then a C, then a delay 1000, and then it loops again. So that's what we got over there. So that's what's inside one of these little cooking thermometers. So this, you pull it out, you got the skewer and the diode lives down the end like that, like so. And then the heat from the food is transferred through the metal into the diode. So let's reassemble it and get it going again, because it's actually a working thermometer. I'm going to fire up the soldering iron. Can unplug that and make it safe. And let's remove the wires that are tacked onto here and into there. We've got the pull-up resistor 22K and a smoothing capacitor 100 nanofarads, a monolithic capacitor. So electrically it's a very simple thing. Right, that's coming up. Let's see if we can put this back the way we found it. So detach those wires over there, like so. Turn off the ironing. Now the first thing I had to do, reassembling the reverse order, is fit the push buttons. Now the battery holder is on this side, so there's your contact pads for the metric or imperial units and on and off. So we're going to do that. Turn it upside down. Then we need some screws which are on the magnet here. Tiny little screws. And we'll put them back in, like so. Another one. Let's see if we can get that into the screwdriver. Right. Two more to go. try and get the screwdriver into the star. Try bracing my hands on the mat. Do not want to drop one of these screws on the floor because it will take forever to find. They really disappear. Right, so now that small end goes over the wire like so. Then you've got two rubber rings. One of them fits over there like that. Then that goes in there. So obviously if you do use this for cooking, be aware of the steam because this thing is not waterproof. So steam does get inside it, it might degrade it. That cap back on and on off. And there you got Fahrenheit. And degree C. I don't think it has any other functions. No, but that's fine. A simple little thermometer. It goes back in its protective housing. And if one's measuring air temperature, it's got a slot here at the end. So that's our thermometer back in one piece. So if I do that, or if you get a bit of flaminess on it, wow, plus 300. Now it's heating up. That's hot. Now 300 degrees C, that is quite hot. I'm not sure if I'd do that. Now that it's coming down, so it's back in one piece. So you've got a diode in the end, okay, and 0.2 or 200 millivolts per degree C is the voltage change across it, because the forward voltage across a diode changes based on temperature. Okay, you can use it as a temperature sensor. That's also why you need temperature compensation in some electronic circuits, because the temperature across the semiconductors affects the voltage across them, and that can affect analog circuits, even digital circuits. So there's various types of temperature sensors. In this case it's solid state using a diode, and I've demonstrated how to hook it up to an Arduino. You just need a bias resistor, and if you want to see the temperature, just use a little LCD display. And there's your code over there, simple bit of code. Alrighty, we can tidy this bench up and I can get this video published, and I'll see you next time for more stuff. Hope you enjoyed it. It was just a quick little video. Thanks for being here. Take care, and I'll see you next time for more stuff. Bye.